Hi everyone, welcome to Old School Chemistry. We're going to talk about the activation energy diagram. This comes from the Jee Main Exam on August 31st, 2021, the 9 a.m. to 12 p.m. test. It's question number 18, and let's take a look at this question. It says, for reaction AB yielding Mn, the following energy diagram is obtained. And this is what they give us. They tell us that X right here is 50, so let's go ahead and write that down. X equals 50. They say that Y equals 45 and that Z down here equals 30. Notice our axes. This is just a progression over time as the reaction happens. On the Y-axis, we're going to have our energy, that's the enthalpy, and they have our H right there. Notice you start with your reactants, and we're going to end with our products, M plus N. So a real quick review on activation energy diagrams. We know that reactants, in order to break bonds, it always takes energy. And that's how we represent this right here. That's the energy that it takes to break those bonds. Now that has a special term. This is our E sub A right here from there to there. So actually our X is the same thing as the E sub A. Minimum energy required for those bonds to break, okay? Now, when we have this beautiful moment when those bonds break, they immediately form the new bonds for the products. This right here is called the activated complex. It's instantaneous, it's fast, it's unstable. We've actually never been able to jump in and really see the mechanism of how reactants change to products, but this is where it happens. Now when those new bonds are formed, so this is going to be the M and N, they're very stable. So they release energy, always. When reactants are broken, that's an endothermic act, it takes energy. When bonds are formed, it always releases energy, that's exothermic. And here we see the exothermic right there. Those stable bonds release energy. So now to look at the totality, the overall reaction, we're simply going to subtract the energy we put in, bonds broken, minus the energy that comes out, the bonds formed. That difference is right here. If I were to stretch this right here, there it is. So actually look, it's the same thing as Y. That is your delta H. And notice in this situation, it's an overall exothermic reaction. You put less energy in than the large amount of energy that comes out. So to answer this question, our delta H is simply our Y. It's 45 kilojoules per mole. One last thing that you'll want to know, the total energy that's released, that's from the top down right here, is called E of A reverse. That's the total energy released when those products are formed. If you need a little extra help on activation energy diagrams, I've posted some up above. You can take a look at those. Hey, so proud of you. Enjoy your chemistry. It's lots of fun. Good work. Thanks.